Today we will discuss Maxwell law of distribution of molecular velocities. As we know from our previous classes that according to kinetic theory of gas, we know that the gas can move in a random way in all possible direction with all possible velocities in random way. So during this random motion, molecules of a gas can collide with one another, and they can collide with the walls of the container as well. Consequently, their speeds and directions are changing continuously because of the collision between them and with the wall of the container. Now we are interested in finding how many molecules are moving with a particular velocity in the particular direction. To find this, we use Maxwell law of distribution of molecular velocities. According to this law, the RMS velocity, root mean square velocity at constant temperature, and number of molecules in a certain range of velocities remains constant, which means at constant temperature root mean square velocity remains constant. Now we will derive this Maxwell law of distribution of molecular velocities. For this, we assume some characteristics of a gas. Some of them are as follows, like this. One of them is the number of molecules in a finite volume of gas in a container is very large, which means there are large number of molecules of a gas in a container. Second one, molecules of a gas are separated by a very large distance in comparison of their size. Third one, all the molecules are always in motion. They never become stable. Since if they become stable, the Heisenberg uncertainty principle become violated, so they never become stable. Fourth one is because the force between them, the force accepted between them is zero except in the case of collision, which means if there is no collision, then there is no force between them, and between two collisions they move in straight lines. The distance between these two collisions is called root mean free path. As we know that in a container all the molecules of a gas are identical and they are indistinguishable. The collision between the molecules themselves and with the walls of the container are perfectly elastic, so the energy of the gas is completely kinetic energy, not potential energy. Now in a container there is a uniformity in the distribution of molecules in available volume. In other words, if there is no external forces, then the distribution of molecules in a given volume is uniform. If dn is the number of molecules in a given volume dV, then dn is equal to n into dV. Here n is the number of molecules per unit volume. Now because the molecule of a gas moves randomly, so all the directions of molecular velocities are possible, and equally all the values of their velocities are also possible. Last one is there are continuous changes in the speed of molecules due to collision among themselves and with walls of the container. Because in the absence of collision, they move with constant velocity, but when the collision occurs, their velocity becomes changed, but in equilibrium, the number of molecules in a certain range of speed is constant. Means if there is no collision, then in certain range of speeds, the number of molecules are specific.